our two circuits that we talked about in the last two videos, parallel circuit and a series circuit. You know what those are, right? Got our series circuit and we got our parallel circuit. BC, no, parallel. This is why I don't write parallel circuit. And we traced how the electrons can flow through it. And in all honesty, any circuit really requires you to trace how the power can flow through it in order to really understand it. And so this video is going to be on combination circuits, and hopefully by now you guys know what those are. Okay, so here's a combination circuit right here that you guys have seen a lot of, right? You've probably seen it in some quizzes and other things. I can leave those. So how do you trace the circuit through a combination circuit? Well, first off, you have to complete the circuit. In your brain. So you've got a positive and a negative, and that's a battery. Okay. And once you do that, then you can flow, or you can actually map the flow. So it goes around, it goes through this one resistor, and then it splits and has two different directions it can go, and then back around and over. And that's how you know it's a combination circuit, because it has both a series element where the electrons are forced to flow through it, and then a parallel element where they can split and divide based on whatever the resistance value is. So hey, there's where those went. I wondered where those disappeared to. Apparently my parallel circuit just went right over them. All right, so let's erase all of this and focus on the parallel circuits. Excuse me. So do we need to remind ourselves that we have a power source? I don't think it'll hurt to remind ourselves that we have a battery here for our circuit to actually be complete. The first thing you need to do with any combination circuit is recognize which part is the series part and which part is the parallel part, which I already circled, right? And you should be able to tell. And you need to keep each part separate, because the amperage on the series part of the circuit over here is going to be the same at any point that's in series. So this wire is in series, this wire is in series, this is all in series. But when the amperage gets here to the parallel part, it's going to split up based on what this resistance is. Okay. And honestly, this is where you guys probably are going to be thanking me, because this is in fact the question bank graphic. All right, guys, hopefully I find a good way to segue back. I had a little bit of technical difficulty, so let me get to where I was at. Get this back. And we already talked about how to collapse this down, but just a quick little reminder that all we're doing is turning this parallel part and collapsing it down and basically creating a series circuit. Okay. And then you have to use your imagination to put the batteries in, blah, blah, blah. And what were our values? We went with 50 50 for R1, 100 for R2, and 100 for R3. And typically these types of questions will give us a total amps. So I'm sorry, a total voltage. So we're going to say 120. We're definitely going to have to go over to the calculator for this one. But at least for the collapse down part, I know we've got an R2 and 3 of 50 ohms. And I just used the direct proportion, right? If we have an R1 of 100 and we have two of those, then all we need to do is take one of the resistors and divide it by the number of resistors, and we get 50. And that actually works all the way through. So if we had 100, if we had one, if all of them were 100, all of our resistors were 100 in parallel, and we had 5 of them, that would get us to 20. Does that make sense? If we had 4, it would be 25, and so on and so forth. So just using that really simple concept to get our RT, all we need to do now that we've got this collapsed into a series circuit is to add R1 to R23 collapsed, and we get an R total of 100, because 50 plus 50 is 100, right? So our RT is 100 ohms, and we can get rid of this. So often these questions will ask us to expand out, to expand back out and ask us about certain points in the circuit. So it may ask us, what is I2? So what is I2? It may ask us, what is I3? And most often it'll ask us, what is I total? Okay. And we can actually find all these answers because we have enough information to do so. IT is actually pretty easy since we have an ET and an RT, and we can just apply our Ohm's law formula to get IT. And I did this earlier on the calculator, and it was 1.2. So let me put that up here. I total equals 1.2 amps. Well, what's not so easy is to see these numbers and then figure out something like I2 and I3. We can figure out I1. I1 equals 1.2 amps. And the reason we know that is because R1 exists in the parallel or in the series section of the circuit where there's only one pathway. So IT equals I1, but that is definitely not the case for our parallel side, because remember, in the parallel part of the circuit, amperage adds up. And so what happens is that 1.2 amps actually gets split, and some of that amperage goes this way and some of that amperage goes this way. And how do we figure it out? It comes back in the end. So the way we figure it out is the big stretch. And there is one question And I have yet to see a person that gets it right. And it just so happens that it's so difficult that um, that even the answer in the book was wrong. And now you're gasping, oh my gosh, the textbook had the wrong answer. Or you're thinking, man, he thinks he knows this so well, he can go against the textbook. And the truth of the matter is that the textbook was written by people. I wouldn't say written by people, but edited by people. And the test banks that came out of it were edited by people that don't know anything about electricity, right? So I have found that there are actually several questions that are wrong. Anyway, we have this problem of the amperage splitting across our parallel section, and we have to figure out how to do it. And the best and easiest way to do that is to actually find out what the voltage is going across our parallel section. So I'm going to get the highlighter out, and we've got our parallel section right here. And how do we figure out what the voltage is? Well, you know, we've got our 50 ohms at R1, right? And we know our IT. So what if we subtract the voltage that's dropped against this series resistor? What's remaining should be the voltage that's coming across our parallel section. So to do that, remember, what did we get for voltage? We had I times R. So 1.2 times 50 comes out to what? You can go to the calculator and do it real quick. 1.2 times 50, and it actually doesn't matter whether it's the other way around, and you get 60. 60 is our E1, our voltage that's dropped across this resistor that's in series. And then it's really simple, and it really should have made sense to you guys by now, the numbers. All you have to do to figure out what the voltage is going across R1 and R2 is to subtract. The voltage stays the same, and we drop 60 volts. We have 120 volts total. If we subtract 60, then we're left with 60, right? And so across this parallel part of the circuit, the voltage, so the voltage for E and E2 and E3 is also 60 volts. And with that 60 volts, we can figure out what the amperage is. Okay, so come back over here. So used to just tapping for erase, even though I found that I can just push a button on my pen. And what is our math to find amperage if we have resistance and voltage, right? E over R equals I. Okay, so 60 divided by 10, easy math. It's 6, right? And this is what railroaded me before. And I had to redo this segment of the video. So let's confirm with Mr. Handy Dandy Calculator. 600, not 600, divided by 10 is in fact 6. Which can't be right. You know what? And this is why I like class setting, because sometimes I make mistakes. And hopefully you guys have figured out my mistake by now. And it's a sad thing that I just barely figured it out. But it's not 6 amps because the resistance is 100. It's not 10. So, oh, I shut my calculator off. Well, I know that math. It's 0.6. So I2 would be 0.6. We know the answer now. I3 is 0.6. Not really sure why that turned out red. 0.6, and if you add those two together, because they're the same resistance, 100 and 100, 0.6 plus 0.6 is 1.2. So because our resistance is exactly the same for both of these resistors, our amperage is splitting up exactly even. And there we go. Now, this is not the simplest that I can explain this. You just have to understand that in a classroom setting, I can go back and I can explain it several different ways. So, again, please just, if you have questions on this stuff, join into the live office session, ask your question. I'll have this here, I'll draw stuff up, I'll try to explain it as many different ways as you need in order to get it. By no means am I trying to be confusing, but I have found that by doing these things via the video, it's really hard to just keep on track um, and do them. You know, if I wanted to spend time and write a script and do this professionally, I would, but I want it to be organic. So hopefully that helped. The last thing I wanted to show you guys was um, something that I do think confuses people about this, and that is that parallel or combination circuits don't always look like what I showed you, right? So here we have a combination circuit where we've got this part in series and this part in parallel, okay? And it would be the same. What we would do is collapse it down into a parallel circuit by using the reciprocal math, or the 1 over x plus 1 over x, to collapse it into 1, at which point it would become a simple series circuit and we could just add the resistances up. Again, for review, once you get RT, you can once you get RT, if you have voltage, you can get IT. Once you get IT, then you can work out everything. You can expand these out and get all the answers. One last picture I wanted to show you. This is actually not a picture, it's a PDF. So I got to go into a different area. In the Uglies book, there is a challenge, and the answer is already given to you, but the challenge is to break it down into what it is. So I am going to put this PDF on the site for you guys to practice and figure out how to do it. And you have to do it step by step. And I'll give you some hints. Each one of these requires some breaking down. You got these that are in series that have to be added together, and then it has to be collapsed with this to then become another series circuit that needs to be collapsed again. And once you get to that point, then it will be a series circuit. So give that a try. Of course, the answer is right there, 100 ohms. So just work it until you get down to your 100 ohms. And thanks for spending the afternoon with me. Hopefully these videos will help you guys do a lot better on the assessment. Like I said in my announcement, I wouldn't accept anything lower than 100 if I were you, because that's 30% of your grade. And what a great place to start from, especially if you struggled before. getting this additional help and really hearing it from a different person, other than, the teacher you had before, may have helped you. And so you get a clean slate. So again, sorry for all the little messages in the bottom. And hopefully these videos help.